So for Physics 211, Project 1, I'm Renee. I'm also partnered with Cole and Sean, and today we'll be discussing our Project 1. So for the project, we have designed a helicopter for the next Mars rover. The helicopter is designed to launch from rest at little t equals negative big T, after which the helicopter flies for some time before landing a known horizontal distance d away. Uh, Big T is an unknown but constant time. And during this motion, the helicopter has the following acceleration as the function of time, where alpha and beta are known constants. Uh, and we are asked to describe the motion of the helicopter, how much time it takes, how long the helicopter spends in the air, and where the helicopter lands. Okay, go. Um, Description of motion. Motion is a fundamental concept in physics, and it is the movement of an object in space and time. Motion is characterized by three different kinds of properties: position, velocity, and acceleration, which will all be seen in our project. For some important information, the known quantities are final distance, which is d, constants alpha and beta, and the acceleration formula we were given. So unknown quantities is initial time, which is capital T, and an important variable or important variables are position, which equals the integral of velocity, and velocity equals the integral of acceleration.
Yeah. All right. Uh, so for a helicopter's motion, we have three equations, one for acceleration, one for velocity, and one for position. And uh, the acceleration equation is the given function that calculates the acceleration of the helicopter at any time. The velocity is derived from integrating the acceleration function, and the position is derived for integrating the velocity function. And it shows the position of the helicopter.
All right, so we have the acceleration graphs split between the x direction and the y direction. As you can see, in the x direction, the acceleration starts at 0 at t equals 0 and slowly decreases linearly. In the y direction, the acceleration increases a little bit, but then drops. And this is all depending on what your t variable is. These are the velocity motion graphs. The velocity in the x direction, as you can see, starts high and then drops as acceleration decreases, drops faster and faster. And in the y direction, the velocity starts at 0 and slowly increases and then drops off abruptly. The position motion graphs in the x direction starts at 0 and then increases and then decreases with velocity and constant accelerate or constant decrease in acceleration. The position in the y direction starts at 0 and very slowly increases until it gains a good amount of speed and then stops. And these positions are very, it's like the general graph, what it's supposed to look like, but changing the variables can make it look very different.
All right. And then for our unit sense making, This is just breaking down the acceleration, velocity, and position equations down to the units, so we can make sense of which variables to plug in and which go where. So for acceleration, it breaks down into meters per second squared on both sides, and so that checks out, and it kind of shows us which variables to use. And then it's going to be the same for velocity and position respectively. So you have meters per second in velocity and meters in distance traveled. And we're able to relate this problem back to our previous problems in this class, because we use derivatives and integrals to go back and forth between acceleration, velocity, and position. And one of the example problems we used in class was a rock being thrown across a flat field, and it gives us angle theta, and it lands a certain distance away from you. And using x and y components of the velocity, we have to determine time and distance. So yeah, that's a
They need to spin at more than 2,500 RPM to actually lift the helicopter off the ground. Ingenuity also needed to be incredibly light. The entire body, including the solar panel, batteries, computers, rotor blades, and landing gear, had to come in at 1,800 grams, or less than 4 pounds. According to the project lead for Ingenuity, Mimi Young,